Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the formulas of finding the point estimation for specific parameters. So for the first one here, we have population mean. So if you want to find the point estimate of mu here is the population mean, which is the parameter. And you can do that by calculating the sample mean, which is x bar, and this is the statistic. Okay, so the formula to find x bar is given by this one, and it is given in this mathematical form, which is this one is the summation process, okay, for xi. So xi here is the data values. And basically, the process here is a very simple process. It's just adding up all the values. Okay, recall what you have seen in high school when you want to find x bar. Basically, x bar is just by finding or by adding up the first value of your data plus the second value of your data plus the third value of your data. And you will continue doing that until the last value of your data or the nth value of your data, and you will divide that with the total of sample size that you have, which is going to be n. Now the formula written in this way is long, and we're just going to save the space by writing it in a compact form as given by this one. Okay, and it looks more elegant, mathematically elegant. Okay, so how to do that is you can see that all the terms here, they are looking very similar with each other, except that this one is the value of 1, 2, 3, and n. The difference is at these small numbers here. So what we can do is we can represent that as xi, 1, 2, 3, and n. We can call this, we can give a subscript I to that, and this one is the summation process to describe this process that you have here. So we use sigma to describe the summation process, where I is equal to 1 until n. Okay, so basically you are going to substitute the value of 1 into I. So you have the first one is x1, and then you will continue with I equals to 2 for this one, I equals to 3 for that one. You will keep on doing that until I is equal to n. So this is the last value, x is equal to n. So basically that is all to this summation process. Okay, all right, so that is x bar. So I'm just explaining the process here clearly because later on you will be seeing a lot of this symbol used in describing the summation process, and it is good if you understand how this is done. Okay, next we are going to talk about the population proportion. So the population proportion is given by this symbol here, and in order to find the population proportion, this is the parameter, you can start by calculating the sample proportion, which is given by p hat. So this is statistic. Okay, so the formula is given by this one, where x here represents the number of events that occurred. Okay, so this is representing the number of events, and for this one, x here represent the values of your data, so different x, different meanings here. N is the same thing, so n is the sample size, and for this one also n is the sample size. Okay, next, if you are interested in finding the population variance, which is given by sigma squared, so this is the parameter, you can do so by finding the sample variance, which is given by s squared. So this is statistic, and the formula is given by this one here. So this is using the summation process, and basically what it says here is that you are going to have the process of adding up x1 minus x bar squared, when I is equal to 1. When I is equal to 2, you will have x2 minus x bar squared. And then you're going to have x3 minus x bar squared. And you will keep on doing this summation process until I is equal to n. So the last term here is going to be xn minus x bar squared. So that is the process described at the numerator part here. So you can see that if you writing the process in this manner, this is a very long process and it takes so much space. So in order to write it in a more compact form, we will use the sigma notation to describe the process of adding up all these values. As simple as that, okay? Right, now next, you can see that x bar here is the mean, the sample mean, which comes from this one. So x bar is the sample mean, xi are all your data values, okay? And at the bottom part, the denominator part is n minus 1, the sample size minus 1. Okay, so if you want to find the population standard deviation, which is given by sigma, what you can do is you can get the sample standard deviation, which is given by S, and this is simply can be obtained. This can be simply obtained by finding the square root of the sample variance. So the one here, the one you have under the square root here is the value of sample variance. So you just take the square root of the sample variance and you get the answer of the of sample standard deviation. Okay. All right. So in this slide, I'm going to talk about the alternative formula to calculate the sample variance. So this is the formula for sample variance. So it looks different than what is given here. And this is an alternative formula when you have a big data and you are working manually using calculator, using your hand. So it is going to be tedious. So this formula is going to be helpful in order to calculate the sample variance when you are in that particular situation, okay? So here I'm going to show you how the formula above is obtained. So we are just going to use simple algebraic operation, and we are going to use the knowledge which you have already obtained during high school. It is very simple. It looks complicated, but it is quite simple. Okay, so let's start off with the one that you already know here. So we're going to consider this formula as our starting point. Okay, this is the basic formula. So s squared is equal to I from 1 until n, xi minus x bar squared over n minus 1. So this is the formula for sample variance. Next, I'm just going to expand this part here. Okay, we're going to expand this part. Recall what you have seen in school, where if you have a minus b squared, it will be a squared minus 2ab plus b squared. So it's just expanding the term in the bracket here. So the same thing we're going to do for this one, okay? So next we are going to continue with expanding it. So it becomes xi squared, okay, minus 2xi x bar plus x bar squared over n minus 1. Right, next what I'm going to do is I'm going to separate the terms here accordingly. Okay, I'm just going to open this bracket and separate them accordingly. So this will become I equals to 1 until n xi squared minus from I 1 until n 2xi x bar plus n I equals to 1 x bar squared over n minus 1. So now I hope you can see that we have already obtained this part, okay, and this part is already okay as well. So what we need to do is we need to change this part here to look like this one. Okay, right, let us do that. Okay, so this becomes, okay, I'm just going to write down here, we need a big space for this one. So this becomes ni equals to 1 xi squared minus, okay, so for this one here, I'm going to take out the values that are constant. So 2 and x bar can be taken outside, because this one doesn't depend on I anymore. It is a constant. The same thing with x bar. It doesn't depend on I. Only this one depends on I because it has a subscript I to that. So we can consider taking out 2x bar. So that will become 2x bar outside of the summation process. So the summation process is here with respect to xi. So that's what happened here. Okay, 2x bar are the constants. So we can consider that to be outside the summation process. You factor out 2x bar basically. Okay, let me just give you an example. If you don't understand what's going on here, let me just give you a simple example. Let's say that we have I from 1 until 3, and let's say we have a constant which is 4, and this is xi. So what happened in this simple process is that you will have 4x1 plus 4x2 plus 4x3. And you have learned in school that 4 can be factored up. So you will be left with x1 plus x2 plus x3. And this is the same thing as having 4 summation process of this one until 3 and xi. So you see, you take out 4 outside, you factor that out. So 4 is a constant, you take out outside. So the same thing with this one, 2 and x bar, they are constant, and you can leave it outside, factor that out. So you will just be left with the summation process with respect to xi. Okay, now for this one here, okay, if you can see the x bar here, x bar squared here is also a constant which doesn't depend on I anymore. So if you take that out, if you factor that out, I'm sure you can figure out that it will become x bar squared. So what is left here is going to be equal to 1. Okay, you factor x bar squared out, so this will be left. The number that is inside here is going to be equal to 1. Okay, and this is over n minus 1. Okay, next. Okay, I'm just going to focus on this part here. Okay, on this part. Recall that the formula for sample mean is x bar, which is equal to the summation of xi from I equals to 1 until n over n. So if you have the summation of xi, this will be equal to n times x bar, right? So that's what we're going to do next. We're going to write down this one here, ni equals to 1 xi squared minus 2x bar, and that one is equal to n x bar. Okay, look at this. If you have this guy, which is similar to this one here, this is equal to n times x bar. Okay, next we have x bar squared, and what is going to happen to this part here? Okay, again, I'm sure that this one, you understand that this is the summation process where you sum up the value of 1 plus 1 plus 1 until n times. So until n times, the result here is going to be equal to n. So here is going to be equal to n. This one will become n. So if you are not clear what's going on, you can always check that out with a very simple example. Let's say that you have I from 1 until 3. This is value of 1. So what happened in this process is you're going to add up 1 plus 1 plus 1. This is equal to 3, which is just the value here. So if you have until n, the result here is going to be equal to n. So that is the logic behind it. So I know this can be confusing to some of you, but take your time and try and visualize this type of symbol with simple numbers, such as what I have shown you here. From 1 until 3, the result will be 3. So what happens if you put it until 5? The result is going to be 5. So if you have n, the result here is going to be equals to n. Okay, right, next we are going to divide that with n minus 1. Okay, so here you can see that x bar and x bar, if you multiply that, you will get x bar squared. So we have 2n x bar squared plus x bar squared n. Okay, so this is negative 2, this is 1. So the result here is going to be xi squared. You can add up because now you have the same n x bar squared. So this is going to be n x bar squared. This is also x bar squared n, which is the same thing. So negative 2 plus 1 is going to be negative 1. Okay, so it's going to be negative 1. I'm just going to erase this. So it's going to be negative 1, which is negative n x bar squared over n minus 1. Do you know what's going on here? I hope you can see that. So this one here, it will be 2 x bar squared n, right? This will become 2 x bar squared n for this one, and this is positive x bar squared n. So you have the same item here, just that this one is negative 2, this is positive 1. So negative 2 plus 1 will be negative 1. So you have negative x bar squared n, or negative n x bar squared, doesn't matter. Okay, right. Next, you can see that now we are just left, we have all the right ingredients already. So this is okay, this is okay, this is okay, negative is over here, we have the same thing. So how do we change this part so that it looks like this one? Okay, so I'm just going to show this part here because I'm running out of space. Okay, so I'm just going to show that part. Okay, how to change this so that it looks like this one here. Okay, so I'm going to do it somewhere here, I guess. I'm just going to erase some of this. Okay, so now I'm just going to focus on this. Okay, so I'm going to write down, so n x bar squared can be written as, what is x bar? X bar is this one. Yeah, so I'm going to write down, this is equal to, x bar is equal to xi, I from 1 until n over n, and it is squared. Okay, this is x bar, so this is x bar, you square it. So this will become n. I'm going to separate the terms here. So this become I from 1 n xi squared over n squared. You see, I'm taking out, consider this term separately. So if you have, for example, a over b squared, this will become a squared over b squared. So this is what I did with this term here. I considered them separately. So we have xi squared and n squared, and this can be cancelled out with another n at the bottom. So we have the final look, which is this one, and it looks exactly like the term given here. So there you go. It looks complicated, but it is not. And if you find it entertaining, well, good for you, because next semester, if you go on with theory of stats and probability, this is what you are going to do mostly anyway. All right, thank you very much for watching.